NENOMATICA, where mathematics meets YouTube excellence. We are going to find the greatest common divisor and the least common multiple of two algebraic expressions. The expressions are 32a cubed and 16ab squared. We will follow a clear three-step plan. Prime factorize, then use minimum exponents for the greatest common divisor and maximum exponents for the least common multiple. Step 1. Prime factorize each expression. 32a cubed equals 2 to the 5th times a cubed. 16ab squared equals 2 to the 4th times a to the 1st times b squared. Step 2. The greatest common divisor is the product of the common factors raised to the minimum powers. We compare the exponents. For the factor 2, we take the smaller of 5 and 4, which is 4. For the factor we take the smaller of 3 and 1, which is 1. There is no common factor b, because b only appears in one of them. So the greatest common divisor equals 2 to the 4th times a, which is 16a. Step 3. The least common multiple is the product of all factors with their maximum exponents across the expressions. For the factor 2, we take the larger of 5 and 4, which is 5. For the factor we take the larger of 3 and 1, which is 3. For the factor b, we take the larger of 0 and 2, which is 2. So the least common multiple equals 2 to the 5th times a cubed times b squared, which simplifies to 32 a cubed b squared. Let us summarize the results. The greatest common divisor is 16a, and the least common multiple is 32 a cubed b squared. In this lesson, we will compute the greatest common divisor and the least common multiple of two polynomials step by step, exactly following the structure shown. First, we write the given polynomials. Then we factor them. After that, we extract the greatest common divisor. Finally, we build the least common multiple. Step 1. Factor p of x and q of x. We will use two classic patterns, difference of cubes and difference of squares. 2x cubed minus 16 equals 2 times the quantity x cubed minus 8. And x cubed minus 8 factors as x minus 2 times x squared plus 2x plus 4. 3x squared minus 12 equals 3 times the quantity x squared minus 4. And x squared minus 4 factors as x minus 2 times x plus 2. Step 2. The greatest common divisor is the product of the common factors with the smallest powers. Here, both p and q share the factor x minus 2. So the greatest common divisor equals x minus 2. Step 3. The least common multiple is the product of all distinct factors with the highest powers. Include the numeric coefficients as well. 2 times 3 equals 6. So the least common multiple equals 6 times x minus 2 times x plus 2 times x squared plus 2x plus 4. Here are the final answers. Greatest common divisor equals x minus 2, and least common multiple equals 6 times x minus 2 times x plus 2 times x squared plus 2x plus 4. Quick challenge. What are the greatest common divisor and the least common multiple of x cubed minus 1 and x squared minus 1? Try factoring using difference of cubes and difference of squares. We will find greatest common divisors and least common multiples using prime factorization. We will follow a clear 6-step structure on 2 sets of algebraic expressions, then summarize the answers and finish with a quick challenge. First set of expressions. We have 32a cubed, 16ab squared, and 8a squared b cubed. Step 1. Prime factorize each term. Step 2. The greatest common divisor is the product of the minimum powers of common factors. We take the minimum of exponents for 2, for a, and for b, respectively. Then simplify to 8a. Step 3. The least common multiple is the product of the maximum powers of all factors. We take the maximum of exponents for 2, for a, and for b, respectively. Then simplify to 32a cubed b cubed. Second set of expressions. We have 6x squared y, 8xy squared z, and 10x squared y squared z, and 10x squared y squared z squared. Step 4. Prime factorize each term. Step 5. The greatest common divisor uses minimum powers across shared factors. We take minimum exponents for 2, for 3, for 5, for x, for y, and for z, in that order. Then simplify to 2xy. Step 6. The least common multiple uses maximum powers of all factors. We take maximum exponents for 2, for 3, for 5, for x, for y, and for z. Then simplify to 120x squared y squared z squared. Final answers. For the first set, greatest common divisor equals 8a, and least common multiple equals 32 a cubed b cubed. For the second set, greatest common divisor equals 2xy, and least common multiple equals 120x squared y squared z squared. Quick challenge. Can you find the greatest common divisor? In this lesson, we will find the greatest common divisor and the least common multiple of algebraic expressions by using prime factorization and the min and max exponent rules. We will follow a clear, step-by-step structure, just like in the example image. First set of expressions. We are given 3 expressions, a, b, and c. We will prime factorize each, then apply the greatest common divisor rule and the least common multiple rule. Step 1. Prime factorize each term. We write numbers in terms of prime powers and keep variables as powers as well. So a equals 2 squared times 3 squared times a squared times b squared times c squared. B equals 2 cubed times 3 to the first times a to the first times b to the fourth times c to the fourth. C equals 2 to the fourth times a squared times b cubed times c to the first times d to the first. Step 2. Greatest common divisor. The greatest common divisor is the product of the minimum exponents across all common factors. This means we take 2 to the minimum of 2, 3, and 4, 3 to the minimum of 2, 1, and 0, a to the minimum of 2, 1, and 2, b to the minimum of 2, 4, and 3, c to the minimum of 2, 4, and 1, d to the minimum of 0, 0, and 1. Multiplying, we get 2 squared times 3 to the 0 times a to the 1 times b squared times c to the 1 times d to the 0. That simplifies to 4ab squared c. Step 3. Least common multiple. The least common multiple is the product of the maximum exponents across all factors that appear. So we take 2 to the maximum of 2, 3, and 4, 3 to the maximum of 2, 1, and 0, a to the maximum of 2, 1, and 2, b to the maximum of 2, 4, and 3, c to the maximum of 2, 4, and 1, and d to the maximum of 0, 0, and 1. This gives 2 to the fourth times 3 squared times a squared times b to the fourth times c to the fourth times d to the first. That simplifies to 144 a squared b to the fourth c to the fourth d. Second set of expressions. This time, the expressions are already written in factored form. We will again use the min and max exponent rules. Step 5. Greatest common divisor for the second set. We take the minimum exponents among all 4 expressions for each factor. That gives 2 to the first, 3 to the 0, 5 to the 0, x minus 1 to the first, x plus 1 to the 0, and x plus 2 to the 0. So the greatest common divisor equals 2 times the factor x minus 1. Step 6. Least common multiple for the second set. We take the maximum exponents among all 4 expressions for each factor. That gives 2 to the fourth, 3 to the second, 5 to the second, x minus 1 to the fourth, x plus 1 to the second, and x plus 2 to the second. Multiplying the numeric part 2 to the fourth times 3 squared times 5 squared gives 3,600. So the least common multiple is 3,600 times x minus 1 to the fourth times x plus 1 squared times x plus 2 squared. In this lesson, we will find the greatest common divisor and the least common multiple of 3 algebraic expressions, following a clear step-by-step structure. Then we will apply the rules using prime factorization, minimum powers for the greatest common divisor, and maximum powers for the least common multiple. First, prime factorize the numerical coefficients, and then keep the variable factors as they are. This gives us clean exponents to compare. Step 1. Prime factorize each expression completely. A equals 2 to the third power times 3 times 5 times x minus 3 squared times x minus 1 cubed. B equals 2 squared times 3 squared times 5 times x minus 3 to the first power times x minus 1 squared. C equals 2 to the fourth power times 3 squared times x minus 3 cubed times x plus 1. For the greatest common divisor, take the minimum exponent of each factor across all 3 expressions. If a factor is missing in any expression, its exponent is 0 there. Now compute each minimum. 2 to the power 2, 3 to the power 1. The 5 term disappears because the minimum is 0. X minus 3 to the power 1. X minus 1 to the power 0 disappears, and x plus 1 to the power 0 disappears. This gives the greatest common divisor equals 2 squared times 3 times x minus 3, which is 4 times 3 times x minus 3. Finally, 12 times x minus 3. For the least common multiple, take the maximum exponent of every factor that appears in any expression. This guarantees all 3 original expressions divide the least common multiple. Now compute each maximum. 2 to the 4th power, 3 squared, 5 to the 1st power, x minus 3 cubed, x minus 1 cubed, and x plus 1 to the 1st power. That gives the least common multiple equals 2 to the 4th times 3 squared times 5 times x minus 3 cubed times x minus 1 cubed times x plus 1. Multiply the numbers. 16 times 9 times 5 equals 720. So the least common multiple is 720 times x minus 3 cubed times x minus 1 cubed times x plus 1. We will find the greatest common divisor and the least common multiple of 3 algebraic expressions, following a clear step-by-step structure. Given expressions: A equals 9x squared minus 81, B equals x squared minus 6x plus 9, C equals 5x squared minus 15x. Rule: factor each expression. We will factor completely before computing the greatest common divisor and the least common multiple. Step 1. Factor each expression. A equals 3 squared times x minus 3 times x plus 3. B equals x minus 3 squared. C equals 5x times x minus 3. Rule: the greatest common divisor uses the lowest powers of common factors across all expressions. Step 2. The greatest common divisor is x minus 3. Rule: the least common multiple uses the highest powers of all factors that appear in any expression. Step 3. The least common multiple is 3 squared times 5 times x minus 3 squared times x plus 3. That is 45x times x minus 3 squared times x plus 3. Final answers: greatest common divisor equals x minus 3. Least common multiple equals 45x times x minus 3 squared times x plus 3. In this lesson, we will factor polynomials, then compute the greatest common divisor and the least common multiple, exactly following a clear step-by-step structure. First set of expressions. We will start by writing the 3 expressions A, B, and C. Next, we will apply the rule. Factor each expression. Step 1. Factor each expression. We write the fully factored forms of A, B, and C. Now, the greatest common divisor. The rule says take the product of the lowest powers of common factors across A, B, and C. Here, the only factor common to all 3 is x minus 2, with the smallest power being 1. Next, the least common multiple. The rule says take the product of the highest powers of all factors appearing in A, B, or C. That includes x minus 2 squared, x plus 2 squared, x squared plus 1 squared, and x squared plus 2x plus 4. Second set of expressions. We will now consider A and B for the second set, and follow the same structure. Factor, then compute the greatest common divisor and the least common multiple. First, write the expressions. Apply the rule, factor each expression. Then write the fully factored forms. Now, compute the greatest common divisor. The common factors are x to the 1st power and x plus 5 to the 1st power. So the greatest common divisor is x times x plus 5. Finally, compute the least common multiple. Take the highest powers of all factors that appear x squared, x plus 5, x plus 3, and x minus 2. So the least common multiple is x squared times x plus 5 times x plus 3 times x minus 2. Let us summarize the final answers concisely. For the first set, the greatest common divisor is x. Welcome! In this example, we will find the greatest common divisor and the least common multiple of 2 sets of polynomials. We will factor each polynomial first, then use the rules for greatest common divisor and least common multiple. Here is the first set. A equals 4 squared minus 9. B equals 4 squared minus 12 plus 9. C equals 10 minus 15. First, factor each polynomial. Let's factor them. A equals open paren 2 minus 3 close paren times open paren 2 plus 3 close paren. B equals open paren 2 minus 3 close paren squared. C equals 5 times open paren 2 minus 3 close paren. Now use the greatest common divisor rule. Greatest common divisor equals the product of common factors with the smallest powers. The common factor among all three is 2 minus 3 to the first power. So the greatest common divisor is 2 minus 3. For the least common multiple, take all distinct factors with their highest powers. From C we take 5 to the first power. From B we take 2 minus 3 squared. From A we take 2 plus 3 to the first power. Therefore, the least common multiple is 5 times 2 minus 3 squared times 2 plus 3. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.